Sometimes we just want to rewrite algebra expressions just because, and here's one way of rewriting this. This could be x squared plus 5x minus 1x. And you see that still gives us the x squared plus 4x, or x squared minus 3x plus 7x. Okay, so you could rewrite expressions in many different ways. One very famous way of rewriting this is actually as a square. Now let's see what happens here. If I decide I'm going to write this as x plus 2 all squared, let's expand it. We get x squared plus 4x plus 4. But we actually, can you see we wanted it as x squared plus 4x. So I could rewrite x squared plus 4x as identical. We'll put the 3 lines there for identical. It's identical to x plus 2 all squared. But you can see that gives us an extra plus 4, so then we would have to take off that 4, and we got that by 2 squared. So we could rewrite x squared plus 4x as a perfect square, x plus 2 all squared, but then adjusted. Now, how that looks visually is a little bit like this. If you put this side as x, and then this is a positive 2, and then this is x and a positive 2, can you see that each of these individual pieces look like this? And so x plus 2 all squared is basically the area of all that square. But if we only want x squared plus 2x plus 2x, if we only want x squared plus 4x, we've literally got to do x plus 2 all squared, but then we've got to take away that little corner piece of square, which is why we have this subtraction there. Okay, so you can always have an x squared plus so many x's. We can always rewrite it as a perfect square, but we'd have to make a small adjustment. Okay, so let's try this one here, x squared plus 12x plus 5. Now I'm going to just ignore the plus 5 at the end for now, and I'm just interested in the x squared plus 12x. So I'm going to rewrite that as x plus 6 all squared. Notice I'm just taking half of the 12, and the reason why that always works is, can you see here, 2 and 2 gives 2x plus 2x. We're always going to take half of this number here, half of the plus 4. So now we just need half of the plus 12, and just play with that. So there's x plus 6 all squared. Now remember the visual, the x plus 6 all squared, there's x plus 6, there's x plus 6, there's the x squared, there's 6x, 6x is 12x, but we get this extra 36 which we need to take away. So I'm going to subtract the 6 squared, but then notice we had that plus 5. So all I'm doing is I'm rewriting expressions in algebra just in a different format. So I unpack the x squared plus 12x, I took the x, put it here, I halved the 12 to put the 6 in here, and then this x plus 6 all squared gives me that extra corner which I need to take off because it isn't in this original expression here. Okay, so the final simplification would be x plus 6 all squared minus 36, and then plus the 5 at the end because that's what I had to start with. So x plus 6 squared minus 31. Okay. This is actually a really good way of trying to solve equations as well. It's called completing the square. We'll do a few more, then we'll solve some equations with this method. So here, even if you've got an odd number, you can still do it. It'll be x plus half of 11. Now instead of writing 5.5, we can just work with the fraction. X plus 11 over 2, always half of that number squared. Then we have to take away the 11 over 2 all squared. Okay, and the reason why it's nice to work with fractions is we can actually just write this out now as x plus 11 over 2 all squared, subtract 121 over 4. Okay, so what we're saying here is that x squared plus 11x can be written as a perfect square, but then we have to adjust by taking off that corner a little bit. Yeah. This last one here, even though we've got negative 4x, and you might think, well, how does that look like if I try to draw the visual with the square and I've got negatives? Well, I think now we just step away a little bit from the visual. You can clearly see that x minus 2 all squared. Can you see that? I'll give x squared minus 4x plus 4. We'd get this extra positive here, again, so we get an extra corner bit that we don't want, so we'd have to subtract the 2 squared. So that would be x minus 2 all squared, and then that would be subtract 4. Okay, let's just pop 2 more in here. If I have x squared plus 23x minus 14, x plus 23 over 2 all squared minus 23 over 2 squared, and then subtract the 14. Okay, this is going to get a little bit more fiddly, but we can still crunch that out. X plus 23 over 2 all squared minus, and this is 529, I think, over 4 minus 14 over 1. We could change this into 56 over 4 if we wanted. And now I think that's x plus 23 over 2 squared minus, what's that, 570 minus 585 over 4. Phew, that's a big one, eh? Just checking my 23 squared, 2400, 465, 20, yeah, that looks okay, 529. And then you're thinking, well, why might this be any good for us? Well, it's good for us for the following. If we have x squared plus, let's say, bx equals, let's say, some kind of answer here. So if we're trying to solve a quadratic, what we can do is we can actually write this as x plus b over 2 all squared, because remember it's just half of this number here. Then we're going to subtract that corner bit of square, and then we just put equals 20 on the other side. And now we can have an idea that says we can actually go ahead and solve this equation, because it's just 20 plus b squared over 4. And then if we square root both sides, we've got x plus b over 2 here equals the square root of 20 plus b squared over 4. This will be a positive or negative answer, so therefore x equals minus b over 2 plus or minus the square root of 20 plus b squared over 4. Okay, so clearly if you put something else instead of the b, like a 3 or a negative 2, then you'll be able to solve equations that way quite easily. And that kind of all builds up to this following equation, that if we want to solve ax squared plus bx plus c equals 0, which is the quadratic formula, we eventually get to x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Now the first steps to do this are as follows. I'm going to divide everything by a. I'm going to take the c to the side. And now I'm going to put into practice what I did previously. I'm going to rewrite that as a perfect square. It's x plus, now remember we take half of this number. So half of this number is just that number divided by 2. So that's b over 2a. But we get the extra bit of square, so I have to subtract the b over 2a squared equals to negative c over a. Now for those of you who want to enjoy the fun and challenge, can you then rewrite that as the quadratic formula, which is the one given below? Okay, hope that helps.